Good morning, students. Welcome to our classes. This topic is regarding to third semester electrical circuits C18 scheme EE 303. In previous classes, we have learned few laws like Ohm's laws, Kirchhoff laws. Based on this basic laws, we have performed few problems. In this class, we are going to learn StarDelta conversion technique to simplify our electrical circuits in easy methods. Let us learn this technique in details. Today, on completion of this class, you will be able to know star or delta connection, delta or mesh connection, transformation delta connected network to star connection to delta connection conversions, vice versa. And based on this, we are going to solve few basic problems, star to delta, delta to star conversions. Now, as we know that our electrical network is a very complex network. It has the number of input sources, that may be thermal power station, hydro power station, nuclear power station, gas, windmill, solar mill, different energy sources connected to our network, and this is connected to the various load categories: industrial, domestic, agriculture, different load categories. Now our circuit becomes very complex, but as electrical students, we should know the performance of our electrical circuits. At the same time, we are going to find that the electrical characteristics like voltage, current, the phase angle between the voltage and current, active power, reactive power, power factor, frequency, etc., etc. Hence, this whatever the our electrical loads, that may be resistors, inductors and capacitors, they may be in lumped or distributed along our transmission lines. These all physical quantities represented with a small simple circuits. These circuits analysis taken place by using our basic formulas. So, basic formula is of Ohm's law. We can apply Ohm's law for a simple circuit where it has only simple active elements and passive elements presents. If number of active elements increases and passive elements connection complicated takes place, then we are going to enhance the from Ohm's laws to our Kirchhoff's current law and Kirchhoff voltage laws. We can solve these problems by writing number of equations based on whether branch current method or mesh analysis method or nodal analysis method. These circuits are very simple, but it is tedious to complete total calculations with equations. To simplify these networks, so we are going to use another weapon, that is StarDelta conversion method. As you see, this is the one simple circuit that consists of active elements. This is the active elements, and where is the resistors? You can see this is a resistor, carbon resistors, the speakers and controlling switches, you can see, and capacitors. So different electronic circuits also placed on a printed circuit boards. As a electrical student, I want to know what is the current in the line which is connected in carbon resistors, another a disc resistor capacitor, and here different resistors connected in different configurations. Then I want to know what is the output of this circuit. Hence, so this circuit is simple, but in electronic circuits, if our applications oriented desires increases, the circuit network also enhances to the complex circuit. This complex circuit can be solved with the help of our techniques like Ohm's law, Kirchhoff's laws, StarDelta conversion, Thevenin's theorem, Norton's theorem, maximal transfer theorem, different theorems also we are going to apply to find its characteristics. Now, this is a simple circuit, but as you know that our power system itself very complex. You can see what is this one? Electrical networks. It has the different ratings of voltage, LT voltages, HT voltages, EHT voltages, EST voltages, and it becomes the more and more voltages, or HVDC also. All these lines connected to our substations as the input lines and output lines, where a different operations takes place in a substations. Then how to know for a particular voltage in a particular device, or what is the current drawn by that particular operators in a substation with these complex networks. That purpose we are going to simplify this. We can write these complex real-time networks into our simple circuits. You can see it, this simple circuit. Here you can see it. Now we can write these complex circuits into our simple circuits what we have seen in first year level. So here you can see it. This is a simple circuit where it has a source, and where is a source and one resistor, another resistor, another resistor. We can easily calculate it with series and parallel circuits. Based on this one, we are going to calculate what is the current across 2 and 3 branch or 1 and 2 branch. Simply applying the V is equal IR. If the circuit complexity increases in second case, then what is happened? Now in this case, we are unable to solve this problem by using our basic Ohm's law. Then we are going to enhance our technique is by applying another Kirchhoff's laws, Kirchhoff's current law and Kirchhoff's voltage law. As you know that the Kirchhoff laws, algebraic sum of currents entering into a node equal to the algebraic sum of current leaving from that node. Sigma I is equal 0 at a node. At the same time, the Kirchhoff voltage law states that in a closed loop, sum of voltage sources is equal to sum of the drops in that loop. So, by using these two laws, we can write by branch current methods, by mesh analysis, by nodal analysis, we can calculate the values. So, whatever you required. For example, I want to know what is the voltage across the B node 2. I can easily calculate. Then I want to note what is the current I2 current across through the R2. I can easily calculate it by using our Kirchhoff laws. Now, if the circuit further increases, you can see here. So, this circuit can be solved using another technique where we cannot solve this problem with help of our already existing weapons, that is Ohm's law and Kirchhoff laws. We can solve with the help of the Kirchhoff laws, but what will happen? Here number of loops are increased, nearly 8 loops, and equations we have to write in 8 equations. So, solving of these equations will take the time consuming method. So, for this complication circuits, we are going to use another technique, that is StarDelta conversion technique. Okay. So, let us see how to solve this type of complex networks with the help of Ohm's law, with the help of Kirchhoff laws, and with the help of star delta conversion methods. Now, what do you mean with the star and delta circuits? As already known in first year level, then you can see it once at a glance. Now, what is this? Star network. You can see star network similar to this simple network. If all the similar ends of resistors are connected to a common point, is said to be star connection. Here what you are observing, here resistors are connected. So, these resistors, one resistor connected here, another resistor connected here, another resistor connected here. For example, this is the one terminal, second terminal, third terminal, and starting and ending, starting, ending, starting and ending. All ends are connected common point. Then it is connected to the supply, this one. That means here we connected the star. The star point, a common point, we can represent it with a neutral. Okay, all ends are connected common, that is known as a neutral, and the remaining starting terminals of all terminals connected to the supply. So, we connect. So, this is another form of star connection. If all the similar ends, that is starting all, or whether you are connected to the all starts or all ends at a common point. If all the similar ends of resistors are connected to a common point, is said to be star connection. Okay. Now, it is also called star connection or T connection because of its physical shape. T shape, it's a alphabetic T shape. Now, coming to the delta. So, now what is the delta? You can see the figure. Similar to the delta, we are connected. Its shape is a delta. Now, what we have seen? So, the here resistors in the previous resistor 1, resistor 2 and resistor 3 is starting and ending, starting and ending, starting and ending. All endings are connected to a common point, that is known as a star. Now, in this case, in delta connection, here the starting ending of first resistor is connected to the starting up the another resistor, and ending up another resistor connected to starting up another resistor, and this ending up resistor is connected to this one. Then we take it outside a common terminal, then we are going to get it. This is the delta. So here you can see it simple. So it may be, this is a phi network, we can say this is a phi network. Previously we had a T network, alphabetic, the phi. So 22/7, just like phi net we can say, or we can say the delta. If the dissimilar ends of three resistors, that is the starting and ending, starting and ending, starting and dissimilar ends of three resistors are connected together, then it is called a delta connection. It is a closed circuit. You can observe here. This is a closed circuit. Here, this is a reference we take in the closed circuit, just like it's a mesh. It is also called as a mesh connection, or we can say the pi 22/7 connection, because it's a shape. So these are the star connection, and this is a delta connection. Okay. Now once again you can see it. What is this one? This is the star network. The star, what is a star network? It is connected all similar networks to a common point. Okay. So if all the similar ends of resistors are connected to a common point, is said to be star connection. Now another connection is the, if all dissimilar ends of three resistors are connected together, then it is called as a delta connection. Simple is required. Okay. This is a star, simple resistors, and this is the resistor, simple, same resistors you connect it in delta fashion, then it is known as the delta connector. Okay. So in our circuits, in our motors, for example, in case of agriculture motor, pump set, induction motor, where it has a stator winding, it has a winding. Actually this winding is a three coils, where is a, one is a R coil, another is a B coil, another is a RB Y coil. Three coils are placed, R phase, Y phase, B phase, R phase, Y phase, B phase, R phase, Y phase, B phase. Three coils are placed here such a way that, and R coil having the, for example, you can see here in our practical applications in induction motors, agriculture pump sets, you have to observe in agricultural level. So where we are going to observe, this is the agriculture pump sets, it will take the water from this one and will gives the water to our fields water. Okay. So this is a one induction motor, three phase induction motor, taking from the wells water. Okay. This motor, three phase induction motor, three phases means R phase, Y phase and B phase. So how they are connected? Here winding R phase having the two coils R phase, for example R phase, and Y phase and B phase, three coils. It is starting and ending, starting and ending, starting and ending. Now all ends, this end and this end and this ends common connected. The remaining, the starting up the ES one coil and starting up another coil, starting up another coil, we taken this one. So now we are going to give the supply to this starting and this starting, R phase, Y phase, B phase, that connection, external connection to our motor. These are the, this one. Internal we are connected to the star or delta. We can connect the star or delta. That purpose we are going to use the StarDelta starter also. Okay, conversion purpose we are going to, another switches also we can connect it. So this is a one practical examples. Okay. Now I think you remember that what is the star. If all the similar ends of the resistors connected to a common point is said to be star point, and if all dissimilar ends of three resistors connected together, then it is called a delta connection. Okay. This is a star and this is a delta connection, you have to remember. Simple connections. Now let us see how to convert the delta to star. You can see here. So, if the star is given in the circuit, here suppose star is given, I want to convert equivalent value of delta. The resistance, for example, R1 is given the 10 ohms, R2 is equal to 20 ohms and R3 is equal to, for example, 40 ohms. Then what are the values connected in star, that equivalent circuit values connected in delta. That means what are the performance, this total value, ohmic value is equal, for example, 50. Same 50 value we are going to get, but in a different fashion in delta connection. What is the purpose? To simplification of our complex networks. Okay, the values are same, but it is connected to the star, that is connected to delta. This is a one helpful technique in solving the problems. Now, let us see how these resistors are connected. Now, you can see here. For example, here star or delta, as you can see here. Three resistors R1, here see it, R1, R2, R3 are connected in star configuration between the three nodes. Here, what is the nodes? You can see it. This is a connected star. So, here you connected, this is the one node, this is another node, this is another node, this is a common node. Then we can say it star connection. Okay. So, here you have remember that star, it has a neutral point, the common point, you are connected to the neutral point. So, this is a common point. Whereas delta, same R1, R2. So, we are going to connect this, the different networks. Now, you can see that one. Three resistors connected in nodes. Here you can see the node, same node. This is the first node, this is the second node, this is the third node. Now, the resistor R1 connected, that is the R12, one term node and two nodes in between resistors, we can represent it as a R12, that is a node 1, node 2, the equivalent resistor, this one. Then R23, that means this is the resistor 23 in between. Or another is a 31, is a 3 terminal and 1 terminal, this one. So, connected in such a fashion that in dissimilar fashion, then we can say it is a delta configuration. Three resistors R12, R23, R31 are connected in delta configuration between the some three nodes, that is a 1, 2, 3 we represented here. Okay. And the transformation formula can be developed by equating the equivalent resistance between the two specified points, and any 2 points we are going to equivalent. Okay. Now, you can see that is here. So, what is the equivalent value? So, whether you are going to given this star equivalent resistance equal to the delta. So, whatever the total resistance is called 50 ohms, we are going to get the 50 ohms, but what will happen? The configuration is changes. Ohmic value is the same, but configuration changes. At that condition, whatever the presence, for example, 10 ohms, 20 ohms, 30 ohms, the total ohmic value is equal to Z, for example, R total. Then here the whatever if connected in another fashion, there is instead of 10 ohms, it may be changes is 10.5, it may be 20 ohms, it may be 25, and here instead of 30 ohms, it may be 40 ohms. But overall ohmic value, we are going to get the same equivalent to the this RT only. You can see one table for easy understanding purpose. Now you can see here. Here, so two resistors, you can see the equivalent resistance between the nodes, the 1 and 2 modes, and star connector and delta connector. Now in between 1 and 2 you can see the circuit. What is the circuit? In 1 and 2 you can see here the circuits are one node, second node and third node. In delta also first node, second node and this node. Now R1 is in star, R2, R3, whereas our delta between the two nodes, that is called R12, R23 or 31, you can remember. That is called R single represented, let us assume star connection, R double 1 2 represented, then delta connection. Remember the resistors. Okay. Now you can see it. Now here connected the, for example, R1 and 2. R12. So what will have the equivalent resistance? Now here resistance, what is the resistance? Now here node is connected, here is node is connected. This is first terminal, this is second. What is the? This is just we are going to take this value. That is called R1 plus R2 connected in series only. Okay. Between the two nodes, first node and second node, third node we are neglected. So there is no current flowing. Simply, what is the resistance between the one and this one? This between, then this simple only. That is called R1 plus equivalent resistance between the two terminals 1 and 2 is equal R1 plus R2. Simple in case of the star. Okay. Now coming to the delta. So delta we are going to, so okay, so we will see clearly in another mode. Here you can see it. Whatever. Now you can see it. Don't confuse it. Here star, here. Okay. So resistance is connected, represented by another color. We can see this is R1, this is R2, this is a R3. Okay. Nodes we are connected here. So different colors we can see. This is a node connected 1, node 2, this is node 3. Okay. Now I want to know that what is the resistance between the node 1 and 2. Okay. Now what will happen? Here the total resistance in this circuit is equal to, now R total between the first node and second node, then R total resistance, and between 1 and 2 node is equal to whatever the current entered, that is flowing only this direction, no connection to the third node. So these R1 and R2 simply we can represent it as this resistance and this resistance, this one. So node 1, node 2, R1 and R2. Then what is the total resistance? We are going to create that simple series circuit, that is equal to R1 plus R2. Okay. So that is equal to R1 and 2 terminals. This is okay. This is in case of the star. Now you can see the same thing in delta. So what is happened in delta? So same, we are going to connect the same nodes. So node 1 and here connected node 2 and node 3. Okay. So here connected node 3 and this is node 1. 1, 2 and 3. Now we are connected resistors. Let us see same resistors. Here is the one resistor connected R1 and next R, these terminals we can represent it by terminal. Okay, you can see this one. Another color we can represent it. Node 1, node 2, node 3. Okay. In between we are going to connect resistance in between 1 and 2. So, the 1, 2 equivalent. Now, we are connecting another resistance between these two. That becomes the R 2, 3. In between we are connected another resistance R 3, 1. Let us assume 3 nodes, there is a 3 nodes connected here. Okay. So, what are the 3 nodes here? You can see it. So, I can take the another color. So, this is a node, this is a 1 node 1, this is a node 2, this is a node 3. Connected between the node 1 and node 2 is called R12 and 23, R23, R31. Now, I want the resistance between the same 1 and 2 node R total, similar to the star connection. Okay. So, we have seen that this 1 and 2 terminals. Then this can be simplified. How we are going to simplify it? So, similarly current is coming here and node 1 here resistance is connected and that resistance is connected and this 2 is going there. Okay. Now, another resistance connected here and resistor connected here. This is the third point. That means I want to know that what is the equivalent resistance across the 1 and 2 terminals. Now, this can be because you can see it R12, R23, R31. So, R31 these two are in parallel combination. You can see these are the series connection and this is another connection. So, this can be represented by simple. So, how we are connected? R12 we connected the one resistance and R31 and R23 is series, you can see it. So, that is represented by this one connected here. Now, this is the terminal 1, this terminal 2. Okay. Now, what will happen? This is a series circuit, this is another circuit. Now, combine these two, we are going to the one circuit. Now, we are going to finally what we will get? So, here we will get it simple the node 1, resistance R 1, 2 and these two networks is connected to the equivalent of this resistance. Then final we are going to node 1, node 2, this is a R total for example T1 total one. Then further we are going to connect this simple circuit, we are going to make it simple equivalent or this one or circuit total T2 for example. This is called this and this is connected parallel. So, we are going to the equivalent of this value. So, node 1 and node 2 in between this is a resistance. So, what is the final we are going to get? That is that, but in star connection you can see it. In star connection we are going to get it simple. So, RT is equal to here resistance between the, you can see the RT it becomes to the this one. So, resistance between the terminal, so 1 and 2 terminals is equal to the R1 plus R2, simple two resistors connected in series. But in case of delta connection, what we have got it? So, here we are going to get R total between the 1 and 2 nodes is equal to, so here 2 resistors connected in parallel. So, R12 parallel with the 2 resistors. What are the 2 resistors? These 2 resistors, that is equal to R23 plus R23 plus R31. 2 are series and this is connected to the parallel. So, we are going to get it, this is the R equivalent. Okay. Delta, whatever the star is connected to the delta across the 2 terminals. Okay. So, what is this one? So, both are connected in parallel. So, we can write it that simply equations as you know that. So, equivalent is equal to R12 into R23 plus R31 by total one R12 plus R23 plus R31. You know this simple basic circuits. Okay, this is equal to resistance, this is equal to, okay, R between 1 and 2 terminal, node 1 and node 2 equal to delta is equal this much resistance, whereas R12 in star is equal simply R1 plus R2. Okay, so whatever the R1, R2 is converted to this value, simple conversion across the 1 and 2 terminals. Similarly, we can write it. So another terminals. Now what we have seen here, the star connection, terminal and 1, 2, 3. So we connected 1 and 2, that equal to, we are connecting same terminals, 1 resistance connected here, okay, 2 terminal and 3 terminals. So now whatever the resistance here connected between the terminal 1 and 2 equal to what is the resistance between the 1 and 2 we calculated. So 1 and 2 terminals we equivalently we calculated. Here is simple R1 plus R2, but in this case what will happen, R12 parallel to this this one combination. Okay, we are going to get equivalent between the 1 and 2. Similarly, now we are going to calculate what is the value, what is the value of between 2 and 3 nodes. So 2 and 3, what is the value of 2 and 3 in star, and what is the value of in delta? After that, what is the value of 3 and 1 equivalent resistance? Then what is the value of 3 and 1 in delta? Similar to the previous case. Now is summarized this. Similarly, we are going to simplify this one. Then what we are going to get? Let us see. So we are going to summarize in table. So what is the table? Here 1 and 2. What is the value we have got it? Now here is the R1 plus R2 in case of the star, and in this case we are going to get that R12 parallel with the R23 and R31 in parallel. Now terminals across the 2, 3 terminals here. Now 2 and 3, this one we are going to calculate. So what is the value we are going to get? So you can see it. So R2 plus R3, simple, this is connected in series. Now here we are connected in this case. So here what is happening? R23 with parallel to the R31 and R12. R12 plus R31 in series, and this combination with parallel with the R23. Okay, so we are going to get this equation. Now another nodes between 3 and 1. So what is the value? Similarly, we are going to get R1 plus R3. Similar this one. Now what is the delta? Delta in this case what will happen? So here R31 parallel with R12 plus R23. Okay, so these are the equivalent resistive values in star and delta conversion, vice versa. Okay, very easy, just you remember these values. Okay, so just how to connect this one, now you can see it. Now based on this knowledge we are going to convert here. So how we are going to convert one simple circuit, that is a delta to star, star to delta in real time. Okay, so based on this one, now we know that, so here we know the star equivalent value of nodes between the 1 and 2, this one, and this one equal to this one. Okay, so R12 equal to R delta in this case. Now 1, 2 nodes, R23 equal to this value in delta, R3 1 nodes is equal to this R3 plus R1 equal to this value. Now, let us assume that. So, here equation 1 where R1 plus R2 is equal to this value and R2 plus R3 equal to this value and R3 plus R1 equal to this value. Now, write these equations and simplify it. Okay. Now, this is equal, on equating the above we can get it R1 plus R2 is equal R12 parallel with R23 plus R31. We can write it, that equation is called number 1 equation. Next, another R2 plus R3 equal to, we can say this is a number 2 equation. Now, another is the R3 plus R1 is equal third equations, what you have derived just now. Now, so you can say equivalent, just do not confuse it. Okay. So, now simple, whatever this terminal R1 plus R2 equal to, we are assumed equivalent value, that is this is the this value, this is the this value across terminal 1 and 2. Correspondingly, next case, and in this case what is happened in this second case, this R12 equal to across the year, and here R12 equal to this value. Okay. So, next terminals, and this is terminal equal to this one and this equal to this one. Simple, what we have seen. Now, just converted delta to star. Okay. 1, 2, 3 we are equivalent to that. Now, let us convert delta to star. Now, by solving the above equations 1, 2, 3, we get the following relations. What is the value? So, here we are going to get R1 is equivalent of star. What is the R1 here? So, this is R1, R2, R3 delta values. This is equal 1, 2, 3. So, this is R12, R23, R31. Now, R1 is equal to, the R1 we can write it is equal to this value equal to. So, how here if delta values is given, now in this case R12 is given, R23 is given, R31 is given, then I want to convert delta to star. Okay. Delta is given equivalent resistance, I want to convert into star across the nodes 1, 2, 3 nodes. Now, here R1 of this resistance R1 equivalent to what is the value of given delta values. The given delta R12, R23, R31, we have the equation, that is the equation. So, substituting these values, we are going to some resistance, that resistance equal to the R1 in star. This value, this value, this value manipulated, we are going to get the R1 value here. Similarly, R2, by writing the same manipulation of this resistance, this equivalent, we are going to get the R2. What is the R2? R2 is equal same. Here, what you are observed, you can see here simply. Okay, here you connected the star, delta. Okay, 1, 2, 3, 1, 2, 3. So, R1 equal to, we are going to get it. So, what is the R1? Here, whatever the R1 equal to, here R12, R23 and R31. Okay. So, this is the one thing. Now you can see R12, this resistance equal to here. So, R12, this one into R31, this equivalent, this into this divided by this plus this plus this, we are going to get it. Okay. So that means R1, if you want to know that, you have to multiply R12 into R31 by R12 plus R23 plus R31. So how to remember this one? That purpose, there is a one technique, you can see it. So what is the technique? You can see here. So here given values are this value, unknown values are this one, R1, R2, R3. Okay. So this is R1 is required, R2 is required, and R3 is required. Now here R1 is required. R1 is, you want to know, color is something problem. Okay, black, you can take it. So now what will happen? Here resistance R1, this is called R3, this is called R2. Now R1, R2, R3, where this values is given. Okay, so this can be just, you can see that one. Okay, you can write this one. Okay, here what has happened? So here the delta values are given. Here R12 is given, R23 is given, R31 is given. 1, 2, 3. Then equivalent values I am going to convert star. I require the star connection values is required. That means delta to star conversion we are going to find 1, 2, 3. Is a 1, 2, 3. So how to know this one? So here terminals R1 is required, R2 is required, R3 is required. Then R1 is equal, simply I can write it. So this value I want to write it simply by seeing the equation itself. Simple, write it. So what is the value? R1. So whatever this equation, simply write R1 is equal R12 into R31 divided by R12 plus R23 plus R31. Simple. How we are going to get it? Now R2. So this purpose, simply whatever the value delta is given, then you are going to convert this one, simply merge the two equations, two diagrams. How? We can see here. Here what is the value is given? Now for example, the given values are this one, terminal 1, here resistance given 2, next we are given the resistance terminal, here we connected the resistance, this one. Okay, 2, 3 terminals, R12, R23, R31 is given. Now I want to convert the another form, star form, then simply convert it. How we are going to convert? Simply I require some star here, convert on resistors and convert to this common pattern. Okay, so here it represented R1, this is called R2, this is called R3. Okay, now write the equations. How you are going to write it? Now R1, R12 is given, R23 is given, R31 is given. I don't know R1. So R1 can be written as adjacent of these values. I want this know. What is the adjacent? Here common terminals, this one adjacent. Write it. Simple, R12 into R31 all divided by sum of the total values, that is called R12 plus R23 plus R31. Simple, this is the value. Suppose I want the R23, in this case I want the R23 values I required, then write the equation. Okay, now I want this value, R2 value. What is the adjacent value? So this is the adjacent value, this is the adjacent values of R2. Then R2 is equal, what is the value given? R12 into R23. divided by, so sum of this value, total value, R12 plus R23 plus R31 values. Okay, simple, we got it. So in center I record R2 is equal this value into this value. This value is the R12, this value is the R23. Okay, by total values. Now I want the another this R3 also. Similarly write it R23 into R31 divided by total value. We are going to get the that equations. Okay. Now you can see here. So R1 is equal to what you are going to get? Simple, this is the R12 into R3. Now R22, this is the adjacent value by this value, and R3 we are going to this value. Now, so you can simply understand R12, this value is equal to this value into this value by total value. You can see this value into this value. Now this value required, so you write it what this value. Now what is the value? R12, R23 divided by total value. This is same, denominator is the same. Okay. Now this into this divided by total value. This is a we are going to get. Suppose I want this value. So this into this divided by total value. This is the same thing, you can observe it. Okay. So this is a simple delta given values to star conversion. Okay. So this is a, so by using the above formula, the network can be transformed into equivalent star network exactly equal values. Okay. Now let us do one simple conversion, star to delta. So here what will happen? Star is given and delta transformation. Okay. So in the previous class we have seen that is the how the delta values are given and that is converted into the star conversion by simple writing the equations. Now what we have got it? So in R1 is equal this value, R2 is equal this value, R3 is equal this value, we known, just we have seen. Now by multiplying 1 and 2, what will get? R1 value known, R2 value known, simple multiply it. Then similarly you are going to get it, this is the fourth equation, simple R1 into R1 value known and R2 value known, just multiply it, you are going to get it R1 1 2 1 2 is the whole square into R23 R31 divided by, that is called common point, this is R12 plus R23 plus R31 is a sum of the values whole square, that is the fourth equation. Similarly, and multiplying the 2 and 3, 1 and 2, 2 and 3, 3 and 1, multiply it. So we are going to get, so this is a one equation. Next multiply the another one, 1 and 3, we are going to the this equation. Now we got it the fourth equation and fifth equation and third equation by multiplying 1 and 2, 2 and 3, 3 and 1. Okay. Now equations 4, 5, 6, add it. Okay, add it. Then we are going to get, this is the one common equation. Okay. Now after that, this equation is equal seventh equation. Okay. Now same value. So what is this value? So substitute the equation first. What is the equation first? R1 is equal to R12 R13 by R1 plus R2 plus R3. Now what you have got it, you can simply see it. You got the equation summing the all values, R12 we know, R1 known, R2 known, multiplying in the first case we are going to get R23 another sum by summed all values, simple. Okay. Then that values we are going to get this value. Now in this case we are going to that simply here you can observe that here R1, R2, R3 equal to here this value. Where is the R1 is substitute from the equation? R12, R13 here R12 R13 or 31 equal by divided by this value equal to R1. Simply you can see it. R12 R13 divided by R12 plus R2 plus R31. So this value is replaced by simple R1. Okay, just simplify the R1. What you are going to get? So R1 R2 plus R2 R3 plus R3 R1 from this one equivalent to what is the value? R23 already existed, and here we are going to write the R. What is the value? That is equal to, so simply we can write it the R1. Okay, so R1 we are going to get it. So now I want to know that here I want to know that what is the R23. Now you keep this value here only. Now R1 you send this one. So now it is going to the here R1. Okay, now what you are getting? So R23 is the delta value. We are going to in terms of star values R1 R2 plus R2 plus R3 plus R into R1 divided by R1. These all are the star values. Now it is converted to the R23. What is R23? Between 2 and 3 terminals equivalent resistance equal to the this star connection values. Okay, simple. What we have seen, once again we can see it. First case, whatever the values, star values is given, R1, R2, R3 values given, then we converted into delta values. So this is R12, R23 and R31. Okay, so R12, so we got it. What is the R12? Here R12, this value. So R12 value we got it. What is the equation? We got it. So that is equal to R1 R2, this one and this two, plus this one and this two, R2 R3 plus R3 and R1 multiplication, this one, this into this plus this into this plus this into this. Okay, all divided by. So here you require the R12. R12 means here you write it, the opposite resistance required here. So here what is the resistance value? This is opposite to this resistance value, that is equal R. What is the value? R3. So simply write the R3. So we are going to the R12. Got it? Don't confuse, just you do it. So here we got this equation. Now based on this one, so we got it R, some animation is problem. So R23 we are going to get this one. So we got it, this is the equation. Okay, so whatever the value star is given, just you remember. Okay, you can go here, whatever the value is given in star. Now I converted into delta. So terminal 1, 2, 3. I want the R12. So R12, R23, R31. Now R23, this one I want to calculate this value known, R1, R2 and R3 is the value is given. So R23 is equal to, what is the value? So here you can see it, R23 is equal to R23 is equal to, so R1 R2, this into this plus this into this plus this into this, you write it here, and required R23. What is the opposite? Here is a R1, you write it the simple R1. So we are going to get this value. Okay, now similarly write the all values. R12 similar total values, you can write it by opposite. What is this one? R3, simple R3, total value by R3. We are going to do the R12. I want the R31, then total value by opposite, this is R2. So we are going to get these values. Simply you can see it. So here R31 is equal R3 simple, R1 simple. What is the 2 and 3 and 1? You got it. What is the remaining? R2. You write it R2 here. This into, you write it. Okay, this is a simple equation, so you can easily understand. Now, what is the concept here? Concept is the mainly concept of transformation from star to delta and vice versa. We convert it. Delta network can be transformed into equivalent star network and vice versa. We converted two ones. Okay, vice versa we are going to do it. It means that the value of resistance in star network can be determined when resistance are connected in delta network and vice versa. Whether the values are given in star, we are going to convert in delta. If the delta values are given, then we are going to convert the star. Okay, so this is a good examples. Now you can see so whether delta is given and we are going to convert the star. So what are the equations? Simple, you write it. R1 delta is given and we are going to convert the R1. So I want this known, this unknown, then I am going to calculate. So R1 is equal, this is right, simply equation here in center. So I want this one, so adjacent divided by total value, and R2 is required. So this into this divided by this total value. So this is another value, this is another value. Now these are the equations you have to remember to convert. When delta is given, we are going to convert the star values. Okay, how to remember this one? So there is one simple technique. What is that one? So simple, already we have. So any arm star R1 or R2 or R3 you want to know, that is called product of two adjacent arms here. So what is the R1? What is the R1 adjacent? This one and this one. Product of R12 plus R31, R12 into R31, product of delta values divided by sum of the delta values. What is the sum of the R12 plus R23 plus R31? This is the formula you have to remember. Okay. Now if star is given, what to do? The star values are given, you are going to convert the delta values. Same, the equivalent delta network can be drawn by determining the values of R12, R23 and R31 from the given star values R1, R2, R3 network. Then in this case, how we are going to remember? Same methods we are going to apply. The resistance between the two terminals is equal to, simple, the sum of the star resistance connected to the terminal plus the product of two resistance by third resistance. Here what is happen? So I want to know that this resistance is equal to sum of the total values divided by opposite value, or we simplify, this is a sum of the star resistance connected to the terminal which is the two connected plus the product of that value plus product divided by third terminal which is connected to the third terminal. Okay. So this already you know it. Now same equations you can see here. So this equation R12, R23 or 31. What are the values? You can R12 means you are going to this one is equal to this value is given. Okay. So opposite, it's a simple R1 R2 plus R2 R3 plus R3 R1 by R3. This is a very simple equations. Okay. You want to this known value total by this opposite value here, opposite to this one, this value, simple write it. What is the value? R3. Okay. I want this value total value by opposite value. What is the opposite value? This value. Then I want to know that total value by opposite. What is the opposite? This is the opposite branch. This is the equations. Okay, and if this is a conversion from star to, if conversion, a star conversion to delta conversion. If delta is given, then how we are going to convert the star? Then this is a 1. Same thing. So R1 you required, then simply write the equations. So here adjacent of these two values by total value. Just you are going to get this one. Okay, these 3 equations. These are the basics. This is a summarization of what we have converted star to delta, delta to star. These are the equations you have to remember. Okay, so I think so we will continue in the next class some problems. Okay, so these are the basic conversion, how we are going to convert a basic conversion, how we are going to star to delta, delta to star conversion takes place, and with help of simple manipulation of circuits, the same equivalent resistors we are going to get it. Okay, so today we are going to stop here, and based on these formulas and these formulas we are going to do the some values. For example, R1 is equal to 2 ohms and R3 is equal to 4 ohms, R5 is equal to 6 ohms. Then how we are going to equivalent values in delta? If delta values is equal to, here is a 10, 20, 30, what are the equivalent values in star? We will do the problems in the next class. Okay, based on this simple techniques. Okay, please go through this one. If having any doubts, we will discuss in next class. Okay, thank you.